Hey everyone! Now in this video I'll be presenting to you these two derivative problems that lead to integration of these such functions. I took these questions from the Singapore Cambridge GCE Ordinary Level Additional Mathematics papers from the year 2023 and 2024. Now these two problems require students to find the derivative of a given function and then using this to find the integral of another function. Now, normally we'll be able to find the integral of these two functions without being given these two boosters, without having the leg up from these two derivatives. Now, suppose that I don't give you these two, and then I straight away ask you to find the integral of this and the integral of that. How are we going to go about that? Let me show you. Let us deal with this integral first. I'm given the integral of 16x plus 8 over the square root of x squared plus x plus 1. Don't forget the dx. I can use a technique called integration by substitution, and in this case I'm going to do a u substitution. What I'm going to do is that I'm going to let the 1 in the square root be my u. I'll let u be equal to x squared plus x plus 1. And what I'm going to do, I'm going to find du over dx. And it's going to be as such, 2x plus 1 dx. Okay, what do I do next? Notice how we have a 16x plus 8 in the numerator. What I'm going to do is that I'm going to multiply this whole thing by 8. So I have 8 du equals to 8 times 2x plus 1 dx. So eventually you're going to end up with 8 du equals to 8 times 2x, 16x. 8 times 1 gives you 8, 16x plus 8 dx. And this perfectly matches up with what I have in the numerator in the original integral. And then I can finally go to performing my u substitution for this one. So what I'll have is the integral of 8 over, I let u equals to x squared plus x plus 1. So I'll have 8 over square root of u du. Then this integral will become a lot more easier to work with. If you want to rearrange it to become negative exponents, then go ahead by all means. So I have 8u to the power of negative half du. So if I just work this out, I'll have 8u power plus 1, negative half plus 1 gives you half, divided by the power. Then eventually 8 divided by half is 16 u to the power half du. And then what I'm going to do is that now I can perform my original substitution. Don't forget the plus c for indefinite integrals. Then I can substitute back my u equals to x squared plus x plus 1. So eventually I'll have 16 multiplied by x squared plus x plus 1 to half plus c. And then eventually I'll have this. So just like that, I've solved this integral without needing the leg up with this derivative. Now let us look at this one. Now this one's going to be a bit more different. We're going to take a little bit more of a different approach to this. We're going to use another integration technique called integration by parts. Now I'm going to do a little bit of a quick recap. Integration by parts here is the sort of formula. I have u dv equals to uv minus the integral of v du. So this u dv represents the product of two functions. Same with this, and same with this. And I'm going to use this to find this integral of x e to the negative 2x power dx. Okay, let me show you how it's done. I'm given the integral of x e to the power negative 2x with respect to x. What I'm going to do in this case is that I'm going to let one of them be u and the other one be dv. Okay, now to do so, what I'm going to do is that I'm going to make u easy to differentiate and my dv easy to integrate. I'm going to let my x be u, I'm going to let e to the negative 2x be dv. And then what I'm going to do is I'm going to find du, I'm going to find v. So derivative of x simply gives you 1. Derivative, so dv, the integral of dv is going to be e to the power negative 2x for negative 2, which is negative half e to the power negative 2x. And then I can apply my integration by parts formula over here. So here's how it's going to look like. So it's x multiplied by negative half e to the power negative 2x plus the integral. So I have v and then my du. So using this one, it's supposed to be a minus, not a plus. Sorry about that. So it's going to be like this. Negative half e to the power negative 2x times 1 dx. Then I can go on to evaluate this one first. Half of x 2x. I can take out the negative, so I get a plus. Integral of half e to the power negative 2x dx. I can take out the half as well, since it's half is just a constant. And then this integral is so much easier to work with. Here's what I have. And then if I integrate e to the power negative 2x dx, I still get e to the power negative 2x. Then I divide it by negative 2. Then I put a plus c over here. Don't forget the plus c. Very important when it comes to dealing with indefinite integrals. And then I can go on to simplify the whole thing. So eventually I get this. And there we have it. If you want to simplify this any further, I can actually factor out the e to the power negative 2x. If you want to do that, then you can go ahead and do it. So I have e to the power negative 2x. And there it is. Now we have used integration by parts, and we've used integration by substitution to evaluate these two integrals without having these two assists that were originally given in the question.